If you are using or considering using rod pump systems, you know that the long-term reoccurring costs of reciprocating rod lift makes it difficult to keep late-life artificial lift wells operating profitably. But imagine if you could use a system that provides all the benefits of rod lift while pumping from lower depths without any of its inherent deficiencies. And imagine that you could use this system more effectively in deviated and gaseous wells without the breakdowns all too common to rod lift. ELC Energy has tackled this challenge not by making the solution more complex, but by simplifying it. The GasPump Artificial Lift System replaces reciprocating rods and a surface pumping unit with a positive displacement system that uses surface-controlled high-pressure gas to provide lift displacement. No more rod and tubing wear, no more rod breaks, no more gas locking issues. Gas pump systems do not use rods or moving reciprocating pumps. In fact, the only moving parts are the balls in the standing valves and the pins in the two downhole valves, and they only move 150 thousandths of an inch. Because gas pump systems use gas to displace produced fluids, the gas pump system will never gas lock. In fact, the formation gas and the injected gas is produced through the annulus. The GasPump Artificial Lift System uses virtually no moving parts and can be installed easily in tortuous wellbores. Let's see how it works. The system uses only a few components to drive fluids to the surface: an on-site gas compressor, a surface control skid, an accumulation chamber with two standing valves, a gas vent valve and injection valve, and a high-pressure gas line and hydraulic line. The standing ball valve allows reservoir fluid to enter the chamber while the chamber vent valve is open and the chamber injection valve is closed. While the chamber is filling with liquid, all the low-pressure gas vents to the surface through the annulus. The liquid accumulation chamber fills with liquid ready to be pushed into the production tubing, which uses a standing ball valve to prevent the fluid in the tubing from backflowing into the chamber. The surface control skid raises the pressure in the hydraulic pressure control line, causing the chamber vent valve to close and the chamber injection valve to open. This permits accumulated high-pressure gas in the gas accumulator injection line to enter the chamber and begin flushing the liquids into the tubing. The pressure causes the chamber entry standing valve to close, isolating the reservoir from exposure to high pressure. And as the injection gas pressure overcomes the hydrostatic pressure of the full column of tubular liquid on it, the tubing entry standing valve is pushed off its seat. The liquid chamber's accumulated liquids are emptied and completely flushed into the tubing, and the chamber is ready to be filled again. At that point, the surface control skid reduces the pressure in the hydraulic pressure line, causing the chamber injection valve to close and the chamber vent valve to open. Without high pressure in the chamber, the tubing hydrostatic pressure closes the tubing entry standing valve, and the chamber standing valve opens as reservoir pressure drives production toward the pressure sink, causing the chamber to fill again for the next flush cycle. This pumping cycle continues for the life of the well. The gas pump system's straightforward design prevents gas lock, eliminates rod failures, and prevents holes in the tubing due to rod wear. It has a simple design, is simple to install, is simple to operate, and most importantly, it is simple to maintain. It is simple ingenuity. Contact ELC Energy Services to see how gas pump lift systems can simplify your operations. ELC Energy, straightforward solutions for the new millennium oil and gas industry.